Hello everyone, today let's talk about experimental error and statistic. This chapter is taken from the analytical chemistry subject. Let's see the content that you will learn today. As you can see, we have 5 things to learn, which is definition, second is importance and key terms, third, error in chemical analysis, fourth is basic statistic, and lastly, data evaluation. But first, before we start, let me introduce myself and my partner. My name is Muhammad Mirzan Ali bin Ansar Ali. You may call me Mirzan.
Hi, I am his partner, call me Fauzan. My full name is Mohammed Fauzan Shafi bin Mohammed Fawdi.
Now let's start our lesson with the definition. In analytical chemistry, measurement is the act of capturing quantitative data with an instrument. The detail you record must match the instrument's resolution. For example, a 50 ml burette marked every 0.1 ml must be read to the nearest 0.01 ml, while a calibrated millimeter ruler is read to 0.1 mm. High-precision devices, such as analytical balances, resolve to about 0.0001 gram, whereas top-loading balances typically resolve to 0.01 gram. Digital pH meters have their own resolution, controlled by proper calibration. Next, let's see the importance in choosing tools. Always choose an instrument whose resolution suits the required accuracy, and record every value with the correct number of decimal places. Reporting either too few or too many digits misrepresents the true quality of your data and can magnify error in later calculations. What about key terms? Good practice aims to identify and correct systematic error through calibration checks, blanks, and reference materials, while careful technique and controlled conditions reduce random error. Ultimately, accuracy tells us how close we are to the true value, and precision tells us how consistently we can reproduce that value. Lastly, for my part, it is error in chemical analysis. Every result carries uncertainty, and we classify that uncertainty into 2 broad categories. First, systematic error, a consistent bias that pushes all readings high or low. It often arises from incorrect calibration, poor electrical shielding, or mistakes in preparing standards. Because it skews results in one direction, it threatens accuracy. Second, random error, unpredictable scatter caused by small, uncontrollable fluctuations such as temperature or pressure changes or subtle reading differences among analysts. Random error limits precision, the repeatability of measurements. Now let's move on to Fauzan parts.
Hi, we meet again. Now let's see what we got here. So the basic statistic represent these 7 parts, which is mean, deviation, range, variance, standard deviation, relative standard deviation, and standard error of the mean. We will go through one by one. The mean represents the average value of a dataset. It is calculated by summing all measurements and dividing by the number of data points. Let's see, for example, if one data has the measurement of 5, 7, and 9, the mean can be calculated when 5 plus 7 plus 9 and divided it by 3, because we have 3 measurement. Deviation measures how far each data point is from the mean. It is an absolute value to ensure deviation is always positive. For example, if mean is 7, and the next data point is 9, we will get the deviation of 2. The range indicates the spread between the highest and lowest values. It is a simple measure of variability, but sensitive to outliers. For example, the range of the data 5, 7, and 9 is 4. Because the highest, which is 9, minus the lowest value, which is 5, we will get the value of 4. Variance quantifies data dispersion by averaging squared deviations. For example, if the deviation is 2, 0, 2, the variance will become 4 plus 0 plus 4, divided by number of sample minus 1. Standard deviation measures spread in original units. It is a square root of variance, more interpretable than variance. For example, if variance is 4, then the standard deviation is 2. Relative standard deviation expresses standard deviation as a percentage of the mean. It is also called as coefficient of variation. It's useful for comparing variability across different datasets. For example, if the standard deviation is 2 and the mean is 7, then the RSD should be 2 divided by 7 and multiplied by 100%. Standard error of the mean estimates how far the sample mean may be from the true population mean. It decreases with larger sample size. Now let's move to the last part of this lesson, which is data evaluation. Here, we will learn about two things, which is Q-test and T-test. Statistical test introduced to ensure data reliability by identifying outliers and comparing results. There are some comparison between Q-test and T-test. First, let's look at Q-test. Q-test detected outliers. How to do it, let's see step by step. First, we need to sort data in ascending order. Next step should be calculating the gap, which is difference between the outlier and nearest value, and range, which highest and lowest value. Then, the gap will divide by the range. Now, to reject the outlier, the Q in experiment need to be larger than Q in table based in the confidence level required. We are done with Q-test. Next, let's look at T-test. T-test compares means for significant differences. It has three applications that used, which is 1 sample T-test, compare measured mean to a known value, 2 sample T-test, compare means of 2 replicate datasets, and lastly, paired T-test, compare individual differences. Let's see what we got here. Q-test eliminate erroneous data in calibration curves. Ensure precision in environmental sampling. And depends on gap, range ratio and critical QQ values. These are the Q-test table for rejection of data. While T-test validate lab results against certified reference materials, compare drug efficacy in clinical trials. This are the practical apply on the real world. It determines if differences are statistically significant and uses confidence intervals and critical t-values. We now almost in the end of our video, but first, let's do some exercise together to help us remember what we learned just now. Let's recap. We now know the meaning of the basic statistic and its use, so read for a second before we start. Now read the question. The question said, you performed an experiment and obtained the following replicate measurements. Data, 12.5, 12.8, 13.2, 15.0, mg/L. Using the Q-test, determine if 15.0 is an outlier at 95% confidence. You may pause the video for a moment to answer the question. Now let's see the answer. Do you get it right? We reject the outlier of 15.0 because it is still lower than the Q table, so we can make conclusion that 15.0 is still in range with the other measurement taken. Let's move on into T-test question. The question asks that a certified reference material has a known concentration of 50.0 ppm. Your lab measures it 5 times, obtaining data 48.2, 49.5, 50.1, 50.5, 51.0 ppm. Using a T-test, calculate range where the true value lies at 95% confidence. You may pause for a moment to answer. Now let's see the answer. Do you get it right? We can compare whether our taken data were in range within the true value. We have reached to the end of our video. We hope you enjoy watching. That's all from us. Thank you very much for watching.